Alright guys, sorry this is a day late. So if we look at SAT problem set 16, this first one actually I think is totally doable by all of you. So if the operation 2 minus I times 1 plus 4i is performed, where I is the imaginary unit, what is the value of the coefficient of the real part of the resulting complex number? So all they're really asking you there to do in a roundabout way is to FOIL that. So we want to FOIL this. And then when we get to our answer, it'll be in the form of a plus bi, where this is the imaginary part, so not the part we want, and this is the real part. Just remember, though, that if I see an I squared, I should eat that boy out of there and change it to a -1. So I think that's totally doable by you guys. The next one, occupation problem. In a restaurant, there are 6 vegetables on the menu, and a customer can order 2 of them with an entree. How many ways can the vegetables be chosen if they must be different? So that's actually something we're not going to get to, and you can probably, there are probably lots of ways you could write it out, where if I have 6 different vegetables, I could call them like B1, B2, B3, B4, B5, and B6, and think about all the possible combinations we can get there, where all my options have to be different, so pairing up 2 of them at a time, where I get all the different pairs, and I can count all those, but that takes a long time. And so, unfortunately, something that we're not going to get to before you take the SAT if you're a junior right now is stuff about probability and how we count large amounts effectively. So this doesn't have to do with probability, but in that chapter we talk about counting large numbers of things, and if those things must be different, then that means we are doing a combination of things, which a combination is represented with a large C. And the way we write it over here is the number of things that I have to pick from. So in this case, 6 vegetables. And then over here we write down a little how many of those things I'm going to choose. And I'm going to order 2 of them. So the way that this looks is 6 choose 2, which is just the shorthand form of a formula that actually looks like n, or n factorial over r factorial, n minus r factorial. Now, a factorial is a really cool thing that we're, again, going to talk about later, but a factorial, like 4 factorial, is just 4 times 3 times 2 times 1, and 6 factorial, which we're going to do here in a second, is 6 times 5 times 4 times 3 times 2 times 1. So whatever the number is, we just multiply down until we get to 1. And so using this formula here with my 6 vegetables that I'm going to pick 2 of, I would have 6 factorial over 2 factorial, and then 6 minus 2, so 4 factorial. Which what's kind of cool here is the 6 factorial, like when I write it out, 6, 5, 4, 3, 2, 1, and the 4 factorial on the bottom, 4 times 3 times 2 times 1, these will all just cancel out. And then I have the 2 factorial up front, so 2 times 1, and this is really just going to be 30 over 2, so 15. Which you can brute force it, but this will just save time. If we can remember it, that's to say, I guess. Okay, the last one on here is a little bit easier, so we're a linear function, so like a y equals mx plus b thing, with a slope of -3, so that's great. Passing through the 0.5 comma 0, I don't think that's my y-intercept, but I can plug in for x and y and find my y-intercept, so 0 equals -3 times 5 plus b, so it's going to be -15, which I'll add over, so my y-intercept is 15. So my equation is y equals -3x plus 15, and they want me to plug in -2, and so I think you can get your answer after that. Alrighty, on the back, problem set 17. If the solution to the equation are a and b, what is the value of 2 times a plus b? So this is a quadratic, and if I am solving a quadratic, I need to be equal to 0, so I'm going to subtract my 9. And I always try to solve a quadratic first by factoring, which I don't think this one will do, which means that I have to do the quadratic formula. Once you get that, you will have two answers, one of which will be where I do negative b plus that number divided by 2. The other one where I subtract, and then I'm supposed to add them up and double it once I get it. So I think you can probably finish that one. And if you do have an extra question on it, ask me in class. All right, occupation problem. What is the y-coordinate of the vertex of this parabola here? So this parabola is in standard form, and I find the vertex by doing negative b over 2a, and then I plug it in to get the y value, which is unfortunately what they want. So I have to find x so that I can plug it in. And so I'd have 4 over 2 times 1, so 2, and then you just plug that boy in to get your y value, and then that's the one you want. Okay, a little geometry down here. So in the figure at the right, EC and AB are parallel lines, so we kind of mark that with the little extra arrows. Angle ECD is 100. And when we're on parallel lines, we have lots of good angles, like vertical angles are equal, corresponding angles are equal, alternate exterior angles are equal. So lots of these are 100. All the other ones are 80 because we have to add up to equal a straight line, so 180 degrees. Then it tells me that AB is the same length as AC. So I can write that in there and show with tick marks that they are the same length, which then means that this guy here is an isosceles triangle. And again, since this is 100, that's 100. And so since that's 100, this is 80. And in an isosceles triangle, the angles opposite of your equal sides are also equal angles. So if that's 80, this is 80. So this is 160. That's how you add that. And I need 20 more to get a full triangle. So what is the measure of BAC? Oh, got it. Alrighty, 18. If f of x is 2x minus 1 and g of x is 3x squared plus 1, find the value of all these things. So again, this is just function notation. It's telling you which function to pick and what to plug in. So I need to go to g and plug in 2. So I'd have 3 times 2 squared plus 1 to get that number. So for instance, I'll do that one with you real quick. That's going to be 4 times 3, so 12, plus 1 is 13. Then I'm going to add that to whatever f of 2 is. So I'm going to take 2, plug it in here, find f, and replace it right there. Now this one, I need to put 1 into f. So I do 2 times 1 minus 1, which is 1. Then I need to take that and put it into g. So I need to do 3 times 1 squared plus 1, which is 4. So that whole thing is 4. So I just need to do 3 plus whatever this is plus 4. So probably more than 17 is your answer. Alrighty, next. Big Gene works out in the gym. Alright, Big Gene. And has a workout routine that consists of 3 minutes with 30 seconds of rest, and then 6 minutes with 1.5 minutes of rest. Realizing that he might not complete the last routine, how many workouts routine does he undertake if he's in the gym from 6 to 9? So I noticed that he was there for 3 hours, but everything else is in terms of minutes, so I changed that to minutes. So I times by 60, so 180 minutes. And his full little workout routine here, or whatever, is 3 minutes and 30 seconds, so 3.5 minutes, plus 6 and 1.5 minutes, so 7.5, for a total of 11 minutes. So like each routine is taking a total of 11 minutes. And we want to see how many of those routines he can do for 180 minutes. So I just divided that by 11, which is not a nice even number, but you're going to do that number plus one more because you're going to start that last one even if you can't finish it. So I don't have my calculator handy. I don't remember what it was, but you guys can do that. Okay, last one here, location problem. So suppose p of x is cx squared plus 9 and c is a constant, so some number. And here they're telling you that when I plug in 3, I got 27. So that's helping me to be able to find c, because in place of x, I can put 3. And in place of p of x, I can put 27. And so I subtracted the 9. I squared this over here and then divided it away. So I got that c was 2, which then helps me to fully write my equation as 2x squared plus 9. And now they want me to take a negative 2 and plug it in. So easy after that, hopefully. Alrighty, on the back, the vertex of a parabola is the point negative 5, negative 9. If g of x is f of x minus 7 plus 20, what is the y-coordinate of the vertex? So here, they're really just shifting where this parabola was by moving it right 7 and up 20. Now this parabola's vertex was already located here, so if I move it right 7, I'm really adding 7 to that. And if I move it up 20, I'm really adding 20 to that. And they want the y value of the coordinate, so I think whatever that is what you want. Alrighty, so this one had me stumped for a moment, mostly because if I have a picture, I'm drawn to the picture, and I noticed that the pictures were different. But I don't think that actually matters. So a farmer wants to build a pen with 4 straight sides. One side is against a river and needs no fencing. So here. He has exactly 95 yards of fencing, and all sides must be a multiple of 5. Possible shapes of the pen are shown in the figure. Vertical posts are spaced 5 yards apart. So how many vertical posts are needed? Since you have 95 yards of fencing and they need to be 5 yards apart, I just divided by 5. But when I divide, I do have to account for the original post. So I'm going to have to add 1 to whatever I get here when I divide because of the original post that I started with. Alrighty, last but not least, I think, yeah, oh my gosh, Venn diagrams, here we go. In the Venn diagram to the right, the circles represent students in a school who are taking French, Spanish, and German. How many students are taking both French and German? And it's super tempting to just find French and German, so 17. But really, these two kitties here, they're also taking French and German. It doesn't say that you cannot take Spanish, so really there are 19. Easy peasy. All right. There you go.